Hello, everybody. Marvellous to see you here. Well done on being selected by your schools and your teachers to be part of your delegations, to be here. For me, as a slightly older individual in the room, not quite as old as Peter, but or venerable, I meant to say, it's actually really, really cool to see your inquisitive eyes. Hopefully, what we're going to do between the three of us is we're going to give you some things to talk about during your syndicate discussions. So that's me. So I'm going to talk to you a little bit about intelligence gathering from space. Cast your historical collective minds back to the 1950s. The end of the Second World War has happened. The key geostrategic issue is the Soviet Union. The Soviet Union, pretty much like Russia today, is the biggest landmass. And if you think back in the 50s, and particularly with the nature of the Soviet Union, it wasn't possible to go into the Soviet Union and find out what was happening there. So we just look at that landmass there and look at it from a West perspective. Right in the middle of the hammer and sickle there's all sorts of interesting things happening with rocketry. Rocketry is new. So rocketry has come out of the Second World War. The V-2 weapons, the German V-2 weapons, have been taken to the Soviet Union and to the United States. There are some really interesting deployments out to the right around Japan, Kamchatka. There are some really interesting places around what's modern-day Kazakhstan, and there are some really interesting places up in the northwest of the Soviet Union around Murmansk. And all of those places have really cutting-edge for the time military technologies that the West was desperate to find out about. So before we did reconnaissance from space, we clearly did reconnaissance from anything that could get high. The Royal Air Force's first mission was reconnaissance. It was all about the first coming out of the First World War. It was about seeing further over the horizon than you can just being at trench level. That was the raison d'etre to get airborne. Of course, once that happened, then everybody started trying to stop the other people being airborne, and then you get air-to-air warfare. But the primary reason to do it was to get cameras airborne, and then the notion eventually occurred that you could drop bombs from airplanes too. So I've got these characters up here. Sidney Cotton on the left is an Australian. He fought in the First World War. He was a naval aviator in the First World War. He got sacked because he was actually quite uncontrollable. In the interwar years, he went to South Africa and did a lot of prospecting. And in that period of time, he did some work developing how you did high-altitude reconnaissance. The reason he was doing that was prospecting for minerals. So it's a geology-based thing. The Second World War starts to look like it's about to happen. Sidney Cotton comes back to the UK, 1938, with MI4 and MI6, and you'll have heard of MI6. They buy the aircraft he sat in now, Lockheed Electra, and they put cameras in it. And he starts flying it as a civilian aircraft out of Berlin Airport, and he makes friends with senior German officers, and he runs tours for those senior German officers over their estates and over their barracks. And they don't realize at all that he's got a camera on board and he's taking photography all the time. Now, interestingly, about a year or two into the war, Cotton again got sacked, because what Cotton was very good at was this startup, entrepreneurial, innovative type stuff. What he wasn't good at was fitting into a much larger machine. But that gave rise to what became the UK and the US's strategic reconnaissance capability. Constance Babington-Smith, an imagery analyst, was the analyst that found the V1s and V2s. So she found something that now today in our sort of what we know would be a very easy thing to spot. But of course the V1s and V2s and all of this stuff around it was completely unknown to her. So it's her persistence that allowed her to recognize that some of the things she was looking at were out of the ordinary, and she carried on looking at them, and eventually she worked out what they were, and the rest became history. Bryce Poe, 1950s-ish, did some of the flights, early reconnaissance flights in one of the early jets up that Kamchatka, the eastern side of the Soviet Union, on his own with cameras. These are the kind of entrepreneurial characters that are involved in this story. It's not completely gone away here. For some of you might remember, 2001 there was an American P-3 aircraft got hit by a Chinese F-7 fighter, and we still fly these aircraft-based reconnaissance missions today. But if you look at the figures on the left there, and you possibly can't quite see that some are red versus black, these are incidents that happen per nation in 5-year blocks. And look how dense those incidents are in the early stage. So it got really, really dangerous. It got really dangerous. And as soon as rocketry was available, the prospect of putting cameras onto rockets seemed like a far better idea. The first ever photo of Earth above the Kármán line. Who knows what the Kármán line is? Anybody volunteer that? It's the layer upon which we say you have gone into space. If you win astronaut wings, you have to have gone above the Kármán line. You don't have to go in the rocket. You could go there in a balloon. You could go there in an aircraft, but you have to go above the Kármán line. And that's a video camera or a cine camera attached to a V2 rocket did that in 46. By 1959-60, where those bad numbers were pitching up on the previous table, you start to see what's called the KH-1, Keyhole 1 mission. The Thor rocket that the KH-1 is on there is the same Thor rocket that was an intermediate range ballistic missile. So what they did is they took the ballistic missile, they put a reconnaissance fit on the top instead of the warhead. We in the UK in the 50s had a space program. It was based on the Thor rockets. It's a real shame that that didn't survive contact. That on the right-hand side is the first image, surveillance image from the KH-1. So there have been KH-1 through to, you'll find on the internet, KH-13, and clearly life has continued since then, but we can't really talk about that. The strategic shock in 1957 of Sputnik going up was a key galvanizer for all of that stuff. What's happening in that big space that's the Soviet Union? They even had a program, and I had a colleague a few years ago who was on it, where they were going to put astronauts on something a bit like a sort of a Skylab type thing, a very small International Space Station type thing, fly that in orbit, and have the analysts reporting by radio. And he was trained to go on that mission. That mission stopped when the science was hacked, the engineering was hacked, to be able to get the material from the satellite down to the ground faster. So if you think about one of the main problems they had was to get the film, this is chemical film, down from space and not have it deorbit with the satellite, with the spacecraft that burnt up. One of the challenges they had was to then catch these tiny little capsules as they fell from space. And believe it or not, they actually only missed 2 or 3 of them. On the KH-1 missions, they launched 12 KH-1s between 59 and 60. Of those, 9 failed. And it was persistent. It was a lot to do with launch problems. And then as you see rocket launches, the stats on rocket launches, around 1960 to 65, it gets a lot more predictable to put things in space. So these things today are the size of double-decker buses, and they do really quite amazing things. So what kind of intelligence work do we do from space? Well, on the left-hand side of the picture there's what we call early warning and tracking. So if you've walked on in the Yorkshire Dales, Yorkshire Moors, you'll perhaps come across that big pyramid at the bottom called Fylingdales. Fylingdales is a radar that uses the troposphere and can look over the horizon. There are examples of that in the Soviet Union, now Russia. There are examples of that in China, because the physics that's required to do that is the same physics everywhere. So when you see these things, you know that nation, that place, has a program and is concerned about intercontinental ballistic missiles. So there's an intercontinental ballistic missile going off in the middle there, and one of the old satellites, a Sibis satellite, which is designed to spot the infrared plumes that specifically come off those kinds of rocket motors, so to give you early detection. And then there's a number of different sort of classifications of intelligence collection, and the satellites at the top there and interesting ground stations. So there's a painting of a facility in Cambridgeshire, and Cotton's aeroplane in the back there as a sort of representation. Then there are other central things like global navigation. With global navigation, we also include timing, and we'll come back to that. Meteorology, oceanography. You're going to hear a lot more about meteorology later. And one of the other cool things about space is it's a very good place to do communications from, over-the-horizon communications. So if you think a little bit about Starlink and Elon Musk and Ukraine, that's a new interesting dimension on that. And then UK Space Command and the equivalents elsewhere do things in the operational space. So there's the flying the satellites, there's the controlling and understanding what's happening, there's the communications element of that, and there's the launch element of that. If we look about turning that into intelligence, so there's an example of what's called a synthetic aperture radar image at the top there. It's kind of hard to, at your range, to see what's on there, but synthetic aperture radar is not a traditional picture. It's a representation of the distance between the sensor and the object that's reflecting the radar data back. So that gives you an awful lot of things you can do with that in the post-processing that allows you to see when things are moving and turning. But as an analyst, it's a lot harder to look at because there's all sorts of things that happens in the geometry of radar imagery that isn't just straightforward looking. On the bottom, a much easier image, and these are both commercial images now. So these images now, top company ISI, bottom company Maxar, these are generating the kind of capability that I was looking at as an analyst 10, 15 years ago at Top Secret. And now it's commercially available. And there are things like signals from emitters, something called hyperspectral, where you take lots of different parts of the spectrum and lay them on top of each other, and you're looking at the physics of the signals. And then there's the bottom one there, black sky, that's what's called a non-Earth image. So that's the ability to flip the sensor around from looking at the Earth and point it out towards a satellite, the moon, something in space. And then broadly speaking, through those sorts of things we do there, we turn it into mission data, we do some analysis on it, and we use it to drive assessments. I mentioned those two commercial companies. So now there's a really interesting opportunity where commercial space can do what has only been the purview of governments in the past, which means that people who can access commercial imagery can now do what governments used to do and only governments used to do, and that's to understand what's happening in the globe, and that's really powerful. Your lives today are completely managed by space capability. Everything you look at online wouldn't happen online if it wasn't for the space-based PNT, if it wasn't for a lot of that data. So there's something there about what we really need to do is grow this. I reckon there's probably about 10 times worth of geospatial intelligence demand than currently is used. All of those government departments that don't use this, all of those commercial entities, there are many, many more uses. This is a huge growth area. But it's difficult. Space is complex. It creates huge attack surfaces, cyber attack surfaces, physical attack surfaces. Understanding how it's all governed and how on earth you visualize that as human beings, small teams of human beings. And building in resilience to that. So one of the first things that gets cut out of any program is resilience, but it's really, really expensive to put it in later, especially if it's in space. So space capability is now so universally critical. If the PNT signal stops, then pretty much we go back to the 1980s. But none of us in this room are fit to go back to the 1980s because we're so used to being in the 2020s. Everything that I had as a 1980s person that allowed me to survive has kind of been surpassed and gone. We've got a really new, harsh reality. You just have to watch television for a small period of time before you see the really febrile and unpredictable geopolitics. Our strategic advantage that we enjoyed in the West for so long has been really quite badly eroded. So, in other words, lots of other people and lots of commercial companies are doing what we used to do at the Top Secret. It's no longer a surprise. So we have to find different ways of finding an advantage. And all of this, and I would suggest anything you do in life, now particularly, requires you to have a really, really strong understanding of geopolitics and socioeconomics, because that's what it all comes down to. It doesn't matter whether you're an engineer, an artist, a scientist. It comes down to that. That's success or failure. So 2 case studies, perhaps just to leave you with, to go and discuss in your syndicate room discussion. I mentioned what would happen if the PNT signal went down. What would life be like? What would go? So banking requires on timing. All of the logistics that you rely on today, Amazon parcels, that requires the timing signal. That timing signal, position and timing activity signal, that could go because somebody jams it, because somebody spoofs it, which is perhaps worse than jamming. When you're jammed, you know jamming is just when somebody sends a noise at you and you can't pierce through the noise to see the signal. If somebody's spoofing, the hardest thing is it looks like a healthy signal, and then you only realize when you drive in the wrong place that it isn't. If somebody actively use a kinetic or a laser weapon to blind, dazzle, destroy those satellite constellations, or if something just happens and a satellite breaks up, then a lot of these satellites are in what's called low Earth orbit, from about 90 kilometers up to about 2,000 kilometers. It's really, really congested. Imagine flicking off a pinball in that sort of environment and how fast things could decay. And then there's another piece here that's quite interesting in the modern world. Who actually owns these assets? So Moody's, a company that Peter and I work with, estimate there are 4.9 million shell companies in the UK. We're not alone. These shell companies often hide illicit activities, but what they really hide as well is ownership. And ownership drives vested interest. So perhaps it might encourage you to think about where Mr. Musk and Starlink start to influence people's use of satellite communications and what that is about. Okay, I'm going to pull stumps there. Thank you for listening. And I'm going to pass back to Peter for the next speaker.